Okay, in section 4.5 here, we're just looking at one video on this concept of linearization. This deals with linear approximations using a tangent line to our function. So if we look at our picture here, we have a function f of x. We have a point of interest, which we're calling a comma f of a. F of a is just a y value, of course, on that function. And we have our tangent line going through that point of interest. Well, recall that we know how to write the equation of the tangent line. This is where we drew in those three boxes. Okay, and so f of a is the y value, a is the x value, and f prime of a is the slope, or the derivative. So we know that already. So what are we doing with it? Well, we're going to use this tangent line equation to make approximations for values really close to x equals a. And then we're going to compare it to the actual value on the function. So this is a lot easier once we look at an example. So here's an example. Okay, so we wish to find the linearization of f of x, which equals x cubed plus 2x minus 3 at x equals 2. We want to use it to approximate f of 2.1. By the way, calculators will be allowed for this entire process. So we begin by finding the equation of our tangent line. So once again, this is where we're going to fill in the three boxes. Okay, we can start by plopping in our x value of interest, which is 2. Well, we need to find the y value that goes with it. So that means we need to find f of 2. So f of 2 would be 2 cubed plus 2 times 2 minus 3. So that's 8 plus 4, take away 3, so that's going to give us 9. So 9 is going to go in this box just like before. We also know that just like before we need our derivative. So this is 3x squared plus 2. And we need that x value of 2 plugged into it. So notice how we're not doing anything with that 2.1 yet that we see in the problem. Okay, we're just doing our traditional equation of the tangent line. So that'll give us 14. So 14 goes in that box right there. So we can clean this up. We can write this as y equals, we'd have 14x, we'd have a minus 28, and then add over that 9. That's going to give us negative 19. Okay, so this represents the equation of the tangent line. Okay, so that's known as linearization. We're using this equation of our tangent line, which we know is linear, and we're going to use it to make an approximation. So it's actually really easy, guys. So all you're going to do now is if we're trying to find f of 2.1, all we're going to do is we're going to replace y with f of 2.1, and we're going to put 2.1 in for x, and then we're going to use our calculator. And when we do this using our calculator, we're going to get exactly 10.4. So that's known as our approximation. Okay, so 10.4, this is equal to our approximate value. Alright, so now what we're going to do is we're going to compare it to the real value. Okay, so let's compare. Okay, so f of 2.1 on the actual function, so not the tangent line, but the actual function, if we were to plug in 2.1 and then cube it and do the rest of it, okay, the real value of f of 2.1, again, go to your calculator, you're going to see that it's always going to be very close. Okay, that's what we get. So this represents the real answer. Okay, whereas up above we're using the tangent line to get an approximate answer. Now we could have predicted in this particular case with this function that the real value is actually going to be more than the approximate value. So if we were to kind of blow this up a little bit at this point of tangency. Okay, here is our tangent line. Okay, this is the point 2 comma, what do we say, 9. Okay, that's this point right here. Now, what we were trying to do in this problem was we were trying to figure out what it is at 2.1. Okay, at 2.1 on the tangent line, we got a y value of 10.4. Now, on the actual function, let me do a little better job drawing this. Okay, the actual function maybe looks like that. Okay, notice how it is concave up. Okay, so f is concave up. So the corresponding value on our actual function, okay, because it's concave up, we can see that it's actually higher than it. And because it's higher, we can expect this to be just a little bit more. So notice how it was just a little bit more, right? 10.461 versus just 10.4. Now, it all depends on the shape of your graph. If it's concave up, concave down, okay? So these points are above one another, okay? It's the same x value of 2.1, but this whole process, it's just simply using the tangent line to approximate the value, okay? So again, this right here, this 10.4, this was an approximation on the tangent line, whereas this point up here, this was the real value on the function. Okay, so that's linearization. It's simply using your tangent line. You're writing the equation just like you have been. Okay, you're taking whatever it is we're looking to approximate, you're putting in the value for x, and then the y that you see here, you're just going to replace with f of whatever. Okay, you're just going to simply plug in, do the math, and get your value. And then typically you're going to be asked to compare it to the actual value. All right, so we're looking to see how accurate the approximation was. So you can see that it's not that far off from the real value.